Dear students, welcome to the second lecture of Cooperative Communication Systems. Last time we talked about some introduction about cooperative communication systems, the prisoner's dilemma, cooperation examples in the nature. Today I would like to map this knowledge about cooperation into the cooperation in wireless networks and mobile phones. There are two lectures planned for that, and both of them will be online, of course. Once again, some of the references to the books. And as I said before, the last lecture was about calculation about cooperation gains for different strategies. We had cooperative strategies that will always cooperate, cooperative strategies that play certain strategies like tit for tat, or even strategies that do not cooperate at all. And we compared these strategies, and there's not a clear winner. It always depends on the number of devices that played a certain strategy, the possibility that the game will even be played, so the possibility to meet. But what we learned is that the best strategy that you can have is tit for tat if you have certain two-on-two games going on. And we also calculated a little bit with the initial settings and how long one cooperation strategy will need to outperform the other. We have some examples for that. So we had this on a notebook. This will be replaced now by Jupyter notebooks. So stay tuned for that. There will be an update on the web page for that. Good. Now coming to the wireless networks. So far we talked about nature examples like vampire bats and monkeys or prisoner's dilemma. Now, in the end, we would like to map this to communication networks. And the wireless networks are the ones that are really the ones where it showed up the first time. And when we talk about cooperation, you have to show mainly two things to a device in order to undergo the cooperation or not. One is the incentive. And in Webster, it is defined as something that incites or has a tendency to incite to determination or action. And you need the benefit, something that produces good or helpful results or effects or that promotes well-being. So one is really the incentive that you do something, and the other one is the benefit, what will come out of it. And the cost is then something that you have to pay to get the certain benefit in the end, right? And the incentive. And the relationship between both of them is that the incentive is the benefit that you might get minus the cost. And if the incentive is larger than zero, you might think that cooperation will take place. And in wireless communication, there has been classical relaying examples. And the first one was really increasing this coverage of a communication network, of a wireless communication network, by relaying. And we will have some lectures about mesh technologies. There you will learn a little bit more about this. But in the very first idea is what happens if devices cannot connect to a base station, for example, because they're too far away. Would the other stations in the middle be helpful in relaying the information? And if you really look into something very simple, like assuming solely the path loss, and you have two scenarios, two strategies. One is non-cooperative, where the base station can only reach the mobile device, then there's connectivity. If it does not reach the mobile device, then we don't have the connectivity. Or in the cooperative scenario, you will see that other devices might be helpful in relaying something. Normally, we would make this on the board, explain this a little bit more in detail. I try to be able to do this also here with my slides. Here's an example that we got from our first book where we explained it in the following. We have a base station and two devices, node A and B. And the base station, or the access point here, can reach the node B with 36 megabit per second. This relates to the Wi-Fi 11A or 11G data rates. And if you know, don't take the highest bit rate, but you go to the lowest bit rate, you have no chance to reach even the node A. So the only way that node A can really reach the base station is by relaying the information. And because of the distance between them, we would assume that node A can really reach node B with also 36 megabit, and then node B has to relay it. The basic question is here, why should node B do that? So if we talk about incentive, benefit, and cost, there are costs involved for node B, but what is the incentive? What is the benefit? So for node A, it's clear, right? The benefit is to get connectivity. And there are not any cost involved because that's the best way to communicate. Even if the base station could reach him with 6 megabit, that it would cost him more energy. But the question is still, why should node B do that? And you can think about forcing this device. You can even say, oh, think about the reciprocal rules from the vampire bat. Maybe this device will help me later on. The problem here is, in order to force him later to do that, you have to recognize it. And detection of cheaters means you have to write down all of the devices you have already communicated with. And this database could be huge. Even if you want to store it in the cloud, there's a lot of transmission going on to understand whether you should cooperate or not. So this is not a very easy and convincing scenario. And therefore, we have to revise the cooperation rules from the previous lecture to really understand why he should do this. Now we change this example only a little bit, and this looks like this. Now you see that node B can transmit with 36 megabit to the access point, and node A could send with 6 megabit per second to the access point. If you compare these two things, the first, it's called direct communication or non-cooperative case. Node A would send with 6 megabits and then node B with 36. And as Wi-Fi, the rule is that you will share it in a fair manner by bits and not by time on the medium. You will always repeat 6 megabit for node B and for node A. Oh, the notation here is not the right one, sorry. And 36 for node B. So this is what we will do. Now, with that, you will see that now there is an incentive for node B to allow relaying. Why? Because if node B sends with 36 to the access point, and then there will be 36 megabit per second to transmit a packet from node A to node B, then relaying it from node B to the access point. If you look at the time that this will need, you will see there is a we save a lot of capacity, and if you only have these two nodes available, there will be more chances for node B to access the channel again. So now there is a clear incentive for node B to help node A to relay. Node B would say, I don't care if I have to forward your packets, and this will cost me a lot of energy. I will get more capacity here. It's a trade-off. So before that, node B has no incentive to relay. No clear incentive if it's not given by the system or some other rules. And here it's clear why there is a beneficial relaying strategy from the point of node B. Okay, so let's look at this a little bit more in detail. If you look at different forms of cooperation, then we have here more or less 4 different zones. One is the forced cooperation. One is technology enabled. The other one is socially enabled. And we have something called altruism. So forced cooperation means if you look at node B, the network operators can tell him, you have to do that. Whatever it takes, if there's a request for relaying, you have to do it. So B and C will not matter in the end, right? This is not very nice, but this could be done from the network operator. The other one is you find a way, and this is this example, where you say there is a benefit, right? And this benefit is larger than the cost, so I have an incentive because I would like to get this free capacity to share it among each other. I have to do more than node A, that's clear, but my benefit is there. And this we call technology enabled. There's something more socially enabled. We will come to this a little bit later. This will break with the benefit because there's a new type of benefit that you see here. And there's something called altruism. So, and this is based on a Hamilton rule from 1964 that says if you have a relationship between the two devices, then your benefit will get as a multiplier with the small r here. So users will not care too much about their own gain, but happy to help. So think about family members, right? Their altruism will spawn. And altruism you will need in this. Forced cooperation and altruism will be in this case, and maybe also socially enabled. This one is more the technically enabled, as you will see later. So if you then look into the incentive, benefit, and cost again, we said the incentive is just subtraction of benefit and cost. If we now bring in the relationship R, very simple, right? Then we say if there's a relative relationship between two devices, then you can boost up your benefit, right? And you know parents would do anything for their children, so this relationship R is nearly infinite in this case. Now, if you look at the two forms here, there is something here in the middle, and we call this social mobile clouds, where the technology enabled, this is something that we can design, and socially enabled is something that has to do something with social networks. We'll show you this later. So interesting is to find ways to make people believe in cooperation because they have a clear benefit by themselves. And we will design the technology in a way that we can really increase the benefit over the cost. So here again, if you would like to see it again, as I said it before, if you need altruism and forced cooperation for the one case where node A is outside the box, where node A is inside the box, with the leverage to tell the node B, either you help me or I will destroy the whole communication by using the 6 megabit, this is technology enabled. You only have to make node B aware of the situation, right? And how can we do that? There will be several examples of cooperations of this type later on or in the next lecture, so stay tuned for that. So the next question is, which resources can we use in a collaborative way? So what is it really that we would like to use? Before that, I just intentionally talked about spectrum, data rate, energy, but what is it? Are there more resources that we can use? And if you look at the evolution of mobile networks, so in the beginning you had, in the back you see short-range communication and cellular networks with some type of coexistent networks, right? So they were there both together, but they did not know that they were there. And in the next stage, there's complementary networks where you say, they could somehow work together in one way or the other. We call this complementary networks. And later on, you can combine them even more to form cooperative networks when you have a combination of license-free and license spectrum, centralized, decentralized, wide area and local area networks, and combine them in a better way. And this kind of evolution is something we would like to discuss right now. So in a classical way, we call it also sometimes the monolithic approach. You have one base station that connects with the mobile devices. And this is really an agnostic way. These devices, they don't know about other devices, right? They don't even care about other devices. And these devices are formed in a way so that they have a strong cellular link and they have enough battery, CPU power, and storage to satisfy the user, right? And you have two users, one way or the other. And this is some kind of nucleus, and inside the nucleus, you're agnostic about the other nucleuses. In the user cooperation, what we have more than before is we have a short range communication between them. And by opening this extra link, we still have the same cellular link here. So it's not tuned by that. You could even virtually increase this, as you will see later. But now we think we have a virtual storage, a virtual CPU, and a virtual battery. Still, they're physically located half-half on both devices, but you can make use of that. Actually, the same for the cellular link, as you will see later. And by combining that, this gives you an extra degree of freedom. And the way you can exploit this extra degree of freedom, this is about user cooperation. So this is, as you can see it, the old world on the left side with slaves, where the mobile phones are more slaves of one of a kind. And the right one, you have this short range communication where we form this kind of clusters here. On the left, you could even think we can also form a cluster, but then we need the link over the network operator. There's no direct physical link, there's only a logical link over the network operator. Even this is some kind of cooperation. Question is, where do we see the benefit and where do we see the cost? And then in the book of mobile clouds, we gave a generic mobile cloud definition where we said a mobile cloud is a cooperative arrangement of dynamically connected nodes sharing resources opportunistically. So all the words are now explained here in the bottom. So cooperative means the social relationship among nodes defines the willingness to cooperate and shape the way cooperation takes place in the cloud. So cooperative, and as we think about cooperation, this must be a big thing, right? What is dynamically? So the wireless channel are prone to temporal and spatial fluctuations. Mobility is one of the things, right? And the devices might join out, and this very quickly. So we have to deal with these dynamics. And if you remember the examples of the nature, they were not so dynamic, right? So the vampire bat detected cheater, but on a very long time scale. And here we have to be prone to these dynamic changes. Then we say connected. Then we say nodes are connected with each other directly. This is peer-to-peer, or logically through overlay networks. This is what you saw here, right? Directly or overlay. And a node can be anything, any form of communication device with capabilities to connect to each other. Could be a sensor network, could be a mobile device, could be both of them. As long as they can talk to each other, you can do something here. And then we said opportunistically, and this means taking advantage of opportunities as they arise. This maps directly to the one sentence you have heard before: real egoistic behavior is to cooperate. And then sharing resources. What are resources? Any shareable or composable entity means of available in the network or embedded in the nodes. So these resources is something that we will talk about now. The question is with whom we will cooperate, right? We had this before, and then we say, okay, altruistic, non-altruistic, and non-altruistic. Non-altruistic is clear. You would even cooperate with people you don't know, right? And altruistic is people you may know, family members, friends, a colleague. And altruistic, you are also between devices that you own yourself. We called it in that time personal mobile cloud, private professional mobile clouds, and public mobile clouds. Something that may come back later in this lecture. And then you look back in history and look at this. Where have we formed such kind of personal, private, or public sharing? And one of the first things that I remember was a mobile hotspot, something that we call today tethering or mobile hotspot, and seems to be normal for others. There was Nokia or Nokia app that you could download way before the iPhone that allowed you to share your 3G connection. And this was very cool. It was called Joiku Hotspot, and you had to pay for the app. But nobody really wanted it because the 3G connectivity, you paid for it, right? So the benefit and cost relationship was really tricky here. And with whom would you like to share that, right? Sure, you could do this with your own devices, and maybe, but not with public people, right? So family is still okay, but for others, maybe you would not do this. Very interesting thing. And then later on, we had different personal mobile clouds. For example, physically mobile clouds, where people really used a mobile phone and plugged it into their laptop, where the laptop now is just a screen with a battery and some keyboard. But the processing power was back here. While here the resource was data rate, here the resource is something different, right? Here's a different form from the Razer project. Linda where you can do something. You can also plug it inside like this, 2 different forms. We also had a startup in the area called Phone Deck that even tried to share resources, but not in a physical way, but in a more soft way. So here you could, for example, get a call on your mobile phone and you see what happens on your desktop. You can react on the desktop with it, take it over. You can even use connectivity. So a more softwareized based cooperation form than what you see here on the left. Good. And this brings me to social mobile networks. Why are they also important? So social networks back at the time, and you can now do more, TikTok or whatever you're using. So the standard things were Facebook, LinkedIn, Twitter, Instagram, and others. And the thing is, you could maybe use them to increase the willingness to cooperate, right? And here's an example how social network worked back in the times. So you had a technology domain that supports some social domain, and that supports an economic domain with advertisements and so on. So there was little way backwards. Now, what you can do when you have social mobile networks, you can break this up. There was a buzzword at the time, mobile 2.0, but now you can establish relationship with the context, so the place. You can relationship with lifelong, and you can use the social mobile networks to offer quick establishment of new relationship. And this is what we say the payoff tolerance, right? When are you willing to wait for something? If you know the people a little bit better, and how can social mobile networks help here? And if you look at the mobile phone, right, you have not only the connectivity with cellular and short range, you had also the mobile sensors around. And these inbuilt sensors, microphone, camera, GPS, whatever, you could use to increase your willingness to cooperate. One of the first implementation was also a Nokia app. It's called Nokia Sensor. You had an app on your phone, and you could state your preferences, and then what would happen if you find people close by, it made a little sound, so you can look around and see for the people. This was just getting people to get people connected with. That was not about sharing some wireless resources with that. Oh, sorry. And later on, there was a different application called Aki, and I would like to show you that.
Meet Stephanie. Every morning she gets up with her cell phone, and time is at a premium now because Stephanie works for a fashion label and there's a lot to do, but right now she has to go to class. On the train she checks her Aki mails. Her best friend Lisa tells her that she was a hot chick, but Stephanie sure knows that. Answering the mail, she misses her stop. Just like so many times before, she ends up somewhere in the middle of nowhere, but happily she bumps into him. He's a stranger, but he's good looking, and he can tell her the way back to the city in such a charming way that back on the train, Stephanie checks his Aki profile. That's one thing Aki can do for you, keeping track of all the people you meet while you got your head in the clouds. It's really time for class now, but no way. Emergency call from the office. She has to visit this fashion show. There she meets a lot of people. Some she knows, some are strangers. Aki tracks everyone so she can contact any of them later. Too late for class now anyway, so why not hang out at her favorite cafe? She asks her cell phone who else is around. Aki looks around, and within a circle of 20 meters it finds him. This is Fred, and he uses Aki too. 20 meters, he's gotta be somewhere. Well, those guys seem to have a couple of things in common. Later, Stephanie goes through this day. This she does at the Aki website. She sees the members' profiles, who she met, when, and how often. This Gabriel guy, she met 97 times before, so maybe it's time to write him a message now.
So this was a pretty cool app at the time, and this was times before Facebook even. So it had some localized sensors that could find out who's around you, and it used to create a social network, right? Way advanced to what we have today, and it was a really cool idea at the time. There were also more of these ideas, and it was pretty easy because Bluetooth signals were still around, right? Nowadays, you have new applications here, social sharing of infrastructure, the idea what I showed you before, so you can share Wi-Fi hotspots that are fixed installed, or like Open Garden, the people that also made the nice application FireChat that was used among demonstrators in Hong Kong, building up your own network. They are building this kind of relays, right? And they all have the same problem, how to create such a thing like a cooperative cluster, how to maintain cooperation, and let people think about that this is a good idea. Benefit and cost issues are here. So if you then think about the three layers of the social mobile networks, now the technology domain, social domain, and economic domain, they support each other even more, right? It's a little bit more, and with that you can make way more money than you could have done before in the old way. So the mobile part brings in something for economic domain, but also for us to maintain our cooperative cluster, as you will see soon. Now, the question is now, how will you extend this, right? How can you extend from an egoistic behavior to altruistic cooperation or socially motivated cooperation? I have here an example. So if I would take the old Yoigo hotspot and I would have an LTE connection and I would like to offer it to strangers, and I don't know the Anna girl over here, and she would like to get access because she's maybe does not have access to the network operators here in Germany. She comes from a different country, and then she will say, okay, let me use Frank's courtesy, and she will use my LTE connection as well. And in order to thank for that, she might use Facebook or Twitter or other things to think about, thanks for, that was very helpful. And Frank would be then very happy that somebody wrote something nice on the timeline whatsoever. So this is now a totally different benefit than you would have seen before. So with that, you could even think about other things like content sharing and talk about it. So if you look at the same movies, the same content, also this will spawn the social networks, and you can build a cooperative cluster with that, right? So if you come back now about the four layers we had, forms of cooperation, we had the forced cooperation, where nobody thinks about B and C, you have just to do it. Altruism is you're stupid enough or nice enough to help anybody who needs help. And then you have the two ways here, technology enabled, where the benefit is clearly done by the technology, so you have a larger benefit than the cost, or your own ego is big enough that the benefit is larger than the cost over here. This is socially enabled, right? But we will come back to the technology enabled because this is way more engineering-like, and we would like to do something in this area. Nevertheless, if you think about cooperative wireless networks and social mobile networks, this is a clear way to the future. And we are talking this for a long time, but you see more and more of these applications coming to light. Okay, next talk will be about the mobile peer-to-peer measurements we did.